Hello everybody, get ready to do lesson 6.7 part 1 of pre-algebra math, part 2, part 3 available here, worksheets and everything else, online tutoring. And our class worksheet today has 36 points and we have 32 points of note-taking, huge amounts of note-taking. You should get your notebook taking guide at the email, students, to get that. Into our bell work today, teachers, mask of Abraham Lincoln's head. So we have a scale problem here. The profile of Lincoln's head on penny has a height of 11/32. Write the scale of the penny to the mask without units. So scale of the penny to the mask. And then the carving of Lincoln's face on Rushmore, 60 feet high. Write the scale of the mask to the carving without units. So again, students, this is for you to complete. Give your students 5-6 minutes, teachers. Okay, so for our solutions, teachers, give your students 5-6 minutes for this. So for A, what we're going to do is divide our height of the mask into the height of the penny to find our ratio here. And we have 11/32 over 9 3/4. And then when we multiply both numerator and denominator by 32 over 11, the inverse of this, we get 1 inch over 28.4 inches, or 1 to 28.4. So the scale of the penny to the mask is to 1 to 28.4. We'll do the same thing down here for the Mount Rushmore carving versus the mask. Write the scale of the mask to the carving without units. So we have the height of the mask again, 9 3/4 to the height of the carving. And we need to reduce the height of the mask to 1 inch. So we're going to multiply both top and bottom by the inverse of 9 3/4. And so that would be 39 over 4. So it would be 4 over 39 by both dimensions here. Convert this to inches. 60 feet is 720, or 60 feet is 720 inches. Is that right? Something like that. Do it on your calculator. And we get 1 inch over 6.15 feet. We put this back into feet, or 1 inch to 73.8 inches. So this would be your scale here. For every 1 inch on your mask, you have a 73.8 inch movement on your carving. Okay, into our lesson today. Notebook, students, this goes in page 1 of your notebook for today's lessons. You wrote ratios, you'll find probabilities. You are rolling a number cube and want to know how likely you are to roll a certain number. Each time you roll the number cube, there are possible results, right? Rolling a number cube is an example of an experiment. The possible results of an experiment are outcomes. When you roll a number cube, there are 6 possible outcomes, rolling 1, 2, 3, 4, 5, or 6. And then an event is an outcome or a collection of outcomes, such as rolling a 1 or rolling an odd number. Once you specify an event, the outcomes for that event are called favorable outcomes. The favorable outcomes for rolling an odd number are rolling a 1, 3, and a 5. The probability that an event occurs is the measure of the likelihood that the event will occur. So there is a lot of vocabulary here, students. Make sure you do this on your class worksheet, page 2. In your own words, students, your notebook entry, define outcomes and define events, and define favorable outcomes and define probability. Okay, into our class worksheet, page 5, probability of an event. The probability of an event when all outcomes are equally likely is probability of an event equals number of possible outcomes, the total number of possible outcomes. You divide that into the number of favorable outcomes, and that will give you your probability of a favorable outcome. Finding a probability, suppose you roll a number cube. What is probability that you roll an even number? So 2, 4, and 6 are even. So there are 3 favorable outcomes. There are 6 possible outcomes. So probability of rolling an even would be number of possible outcomes on a dice would be 6. And then the number of favorable would be 3. So this would calculate your rolling an even number. It'll be 1 out of 2. It'll be 50-50. Okay, into our guided practice. Suppose you roll a dice. What is the probability that you roll a number greater than 1? Students, this is yours down here. Pay attention so you can do your independent practice. Guided practice here, probability of rolling a number greater than 1. So favorables would be 5, and then all possibles would be 6. So the probability that you roll a number greater than 1 is 5 out of 6. Experimental probability, as in example 1, is an example of a theoretical. Probability is based on knowing all the likely outcomes of an experiment. A probability that's based on repeated trials of an experiment is called an experimental probability. Each trial in which the event occurs is a success. So experimental probability is the experimental probability of an event is number of trials divided into the number of successes. So that would give you an experimental probability. Number of trials and then the number of successes derived from that. So there is your next vocabulary sheet, students. Enter that into your notebook. Example 2, find experimental probability, miniature golf, 44 out of 256, made a hole-in-one. Find experimental probability that a golfer makes a hole-in-one on the last hole. Number of trials, number of successes. We have 256 trials here. How many successes? So what does that calculate into? It equals 11 over 64, which is some percentage, by the way. Makes a hole-in-one is 11 over 64, or about 0.17. That's pretty low of success. Into our next guided practice. You interview 45 randomly chosen students chosen for the newspaper. Of the students you interviewed, 15 play sports. Find the experimental probability that the next randomly chosen student will play sports. Students, this is yours down here. We're going to do our guided practice right now. Probability to play sports, 15 out of 45, 1 over 3. So the next randomly chosen student will play sports is 1 out of 3. So that would be an example of an experimental probability. And that is lesson 6.7, part 1. Part 2, I think there's only 2 parts, so you can get that here. You can get worksheets, quizzes, and everything else at this email. Thank you very much.